The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to today's Tech Talk on commissioning VRF systems. My name is Sherry Adams, and I'll be the moderator for today's session. Please note that throughout the Tech Talk, all phone lines will be muted. This will minimize any background noise or feedback that could distract from the presentation. When you first joined, an attendee control panel appeared on the right side of your desktop. On the left side of this control panel is a small tab with an arrow icon at the top. Pressing the icon allows you to minimize and maximize the control panel. When maximized, you could use the control panel to submit questions. We'll be gathering any of your questions throughout the Tech Talk, and we'll leave a little time at the end for Q&A. If your question is related to a particular slide, please include that number of the slide in your question. A PDF of the slides from this presentation will be sent electronically to all those who are registered for today's Tech Talk. We will also be recording this Tech Talk, and it will be available on our website under the resource section. And everybody will be getting a new Tech Talk password to be able to log in to view that after the presentation. Today's presenter is Thomas Cocker. Thomas began his career in test and balance, then moved to mechanical design and commissioning. After a few years with mechanical design, he decided to just focus on commissioning and started working for Page. Currently, he's doing test and balance again at Page. Thomas is a professional engineer, TAB certified professional, and a commissioning professional. So Thomas, I will pass the presentation to you.
Thank you. Good morning or afternoon, depending on where you're at. And I'm going to try and keep this presentation around 35 minutes long, so there will be time for questions and discussions at the end. These slides will go over some basic principles and design options for a VRF system, in case you have never encountered one before. I will also go over some procedures you may want to follow and some issues you may come across during a design review, a field review, or functional testing. So what is a VRF system? Well, VRF stands for Variable Refrigerant Flow, sometimes referred to as a VRV or Variable Refrigerant Volume. These systems typically have a single outdoor unit or multiple tied together outdoor units that serve a single line set that enters the building to serve multiple indoor units. And in the outdoor unit, they're typically comprised of a variable speed inverter compressor, and they have a high turn down rate, some as low as 10% of their max speed. And so they usually come with a package. Sometimes that's just a single variable speed compressor. It could also be a fixed speed and variable speed compressor, or just multiple variable speed compressors, which allow for that high turn down rate, but obviously they'll be a little bit more expensive. So the outdoor units also have variable speed outdoor fans, which allow for greater efficiency. And the variable speed fans on the outdoor units can modulate to accommodate the changes in load. There are water source outdoor units, which exchanges heat with water instead of air, but we're just going to talk about the air-based ones. Outdoor and indoor units. So due to the fact that these units are heat pumps, we have to change what we call the outdoor unit. And I still mistakenly refer to it from time to time as a condensing unit, which is technically wrong since it can be both an evaporator and a condenser. These systems utilize 2-pipe and 3-pipe configurations, which we'll discuss in the next slide. And they can either be just a straight heat pump or heat recovery. And so a heat pump system can only heat or cool based on the largest number of thermostats requesting each state. And what I mean by that is if you have 10 indoor units and 6 of those units are requesting cooling, then the system will go into cooling. If you have 6 indoor units requesting heating, then the system will be in heating, regardless of what the other ones are doing. And then you also have the energy recovery system, which can actually do heating and cooling simultaneously and is extremely efficient while doing so. So if you're lucky enough to get on the project in design phase, I would suggest doing a design review. And even if it's not part of your scope and you come on the project and construction phase, it still is ideal for someone to do a design review, because the earlier you catch issues, the better it is downstream for pretty much everyone involved. So during a design review, what do you want to look for? Well, first, what type of system is it? Is it the heat pump or the heat recovery system? And like previously discussed, this will change the way you approach your design review. Does it make sense for the system to just be a heat pump? Will the system serve spaces that need constant cooling and spaces that need both, depending on the load and time of year? There may be situations when a system serves both a server room and an office space. If the office space is cold and it has, the majority of the indoor units on it, and the server room is hot, you may have situations where the system will switch to heating and heat the server room. So you may want to recommend the engineer place all server, electrical, MDF, and other rooms or other similar rooms on their own dedicated system. So next is a 2-pipe or 3-pipe system. So a 2-pipe system is done by one manufacturer only, and basically sends a multi-state gas liquid to the branch selector to be distributed to each indoor unit based on cooling and heating requests. The 3-pipe system is used by all other manufacturers. There are advantages and disadvantages to each, but we don't need to dive into those, since we don't make those unit selections. We just deal with the aftermath. So we just need to know the differences. So one main question to ask when you're doing your design review is will it be monitored by the BAS? And the points required from the engineer, are they possible without extra sensors and options? We need to know as commissioning providers the end goal for the user interface and whether or not it's possible. Typically, VRFs allow for very little third-party control of the units. They also do not have many monitoring points available. I've seen, sequences state that the BAS will control outdoor unit fan speed and compressor, and when the compressors will energize and how to modulate the compressors, which, if the sequence is stating that, then you should know that generally the manufacturers will not allow the BAS to control the units to that level. They, they know how to control their units best, and BAS will typically just monitor and schedule. I've also seen dirty filter alarm sensors shown on the sequences as analog DP sensors, which would, need to be done by the BAS. It may not be an option that's available, from the factory with that unit. So the design review is the time to bring all these issues to light and trying to let everyone know, clarify sequences so that control contractors are aware, so that they know to purchase these items and not issue change orders that can delay projects downstream. Other things to look for. So you want to look at the distance between the outdoor unit and the furthest branch unit, furthest branch selector unit, and the furthest indoor unit for refrigerant piping and control wiring. And so this is horizontal distance, and where you can find this is usually in the install manual. They'll have these diagrams, which I've shown an example of 2 of them, showing the distance allowable from the outdoor unit to the branch selector, and then from the branch selector to the furthest indoor unit. And it's you receive drawings typically on PDFs, and there's a lot of softwares out there these days. We use Bluebeam or RevView you can set the scale in there, and then you can actually just measure the line length inside Bluebeam, and it's really quick and easy, and it just it helps you out downstream, just because if one of these lengths are too long and no one catches it, then they may have to actually move a condensing unit to account for the further indoor units, or they may have to take the indoor units and move them to a completely different system. That may end up putting an outdoor unit, in a spot where the owner wasn't originally anticipating, and it could be an eyesore. So catching these issues up front is very valuable. Other things to look for are vertical distance for your refrigerant piping. So this allowable distance actually changes depending on whether or not your outdoor unit is at the top of the building or at the bottom of the building. So you can see if it's located at the bottom of the building and having to pump up, then you'll have less distance that you can pipe to than if it's at the top. So that's something to take into account. Other things to look for. So the capacity of your indoor units versus their associated outdoor units. You know, some manufacturers allow their outdoor units to support up to 50 indoor units. And so it's worth it to just quickly go through the schedule, add all those up, and make sure that, you know, they're not over the capacity of the outdoor unit. And I'm not too sure yet if they're starting to put diversity on these types of units. I haven't seen them in jobs, so that'd be something I'd be interested in learning if anyone knows if they've seen diversity on their projects with these units. So please let me know after the presentation. Other things to look for is the mechanical details. Make sure they represent the system to be installed. There's so many times that I see on the project, there's wall-mounted units, cassettes, ducted units, and the outdoor units, and there's not a detail for any of them. So that's something just to verify that each one of those has its own detail so the contractor knows how to install it. And in case there's anything extra that the engineer wants in there, they'll know in the details. You also want to look at the correct use of the indoor unit for the space it's, you know, serving. So, you know, there's a lot of reasons for looking for this. And one big one is, you know, engineers receive drawings from the architects and they are absolutely blank. And so then they fill those drawings with their ductwork and units and everything like that. And then, you know, they make the perfect drawing in a manner of speaking, and then they send that off for that revision of the drawing. And then the architect and the owners get together and they decide to swap some spaces around, you know, and then they send it back to the engineer for the next revision. And so all of a sudden, what was a storage room could now be an electrical room or some other sort of space. And what once had a ceiling grid no longer does. And, you know, the engineer could miss that. So it's worth looking at that. And all of a sudden you have this cassette sitting in this room with no ceiling grid. It's not technically the proper use for that. And it's kind of an eyesore. So if you can catch it, let the engineer know, hey, it may be better if you put in a wall mounted unit here. You know, they'll probably be pretty grateful for that. Other things to look at. So how will outside air be delivered to the space? There's three main ways that I've seen. And so you could use a VRF DOAS unit, you could use an ERV unit, and a dedicated outside air rooftop unit. There are advantages and disadvantages to the VRF DOAS. The ease of design and energy efficiency are a couple of advantages. You can simply run the ductwork into the back of a ducted FCU or cassette, or you can run the ductwork directly to the space and provide neutral air. But if it is going to run directly to the space and provide neutral air, you know, look at the model of the unit that they've selected and make sure it has reheat to get that neutral air. There are disadvantages. So originally you could not control fan speed through the BAS for certain manufacturers of these DOAS units. And that's probably still the case for most of them. So that would make demand control ventilation impossible. Another disadvantage is the capacity limit with these units. In general, the units can only handle about 1,200 CFM of outside air, about 112,000 BTUs. So to overcome the capacity issues with the VRF DOAS, you could use an ERV. The ERV has a lot of advantages. You can route the ductwork in similar ways to the VRF DOAS into the spaces or into the back of an FCU. It can be routed to, it utilizes energy recovery. You can have the ability to pressurize the building while also relieving the building. and it's customizable for most situations. A few disadvantages are the size of the unit and the ability to actually route, both exhaust or return and supply to and from this unit in its installed location. It just may not be feasible in all situations. So you could, maybe there's some situations where you would want to combine an ERV and VRF DOAS. Another issue is that they're also very complex units, so some field installers and programmers may not understand how to successfully set up the unit. There is potential for cross-contamination through the energy wheel, but usually is negligible. The last method I see is the dedicated outside air rooftop, and some advantages to this is they're simpler and they avoid cross-contamination. So once you're done with your design review and you start moving into construction phase, you're going to want to capture some documentation from the contractors. And so what do you want to capture? And so we suggest capturing the startup report. And what you could do is have the contractor submit to you a blank startup report, which would indicate all the fields that they're going to fill out. And so you could make comments on that. And what I would suggest, at least seeing on that startup report are amps, volts, and phase on each compressor and fan. And then also the final refrigerant charge. And so how you can check them on that is you can actually utilize the manufacturer provided charts for the refrigerant charge. And those are in the install manual, or you can use the VRF selection software. And so I've found that the VRF selection software is a little easier to use, and you could probably get it for free from a distributor or vendor. Other things that you want to capture is the pressure test results. So typically for the positive pressure test, manufacturers require about a 500 to 600 PSI pressure test. I'm not sure why, some manufacturers request a different PSI charge than others, because to me, it's all refrigerant piping. But, they all request a rough amount. You can check the install manual to see exactly which one they require for this specific manufacturer. And then they'll also, after the pressure test and it passes, they'll do a vacuum test. And so they'll typically vacuum it down between 500 and 750 microns, and then check to make sure it doesn't gain pressure over a certain amount of period, because no system's perfect. They're all going to leak, but you want to leak obviously as little as possible, and that'll determine whether or not it passes. So other than the startup report, and depending on the project, you also want to capture the duct pressure test report. So, if the building is located in, a third world country or somewhere where people just, it's tough to get installers back out to, there'll probably be a duct pressure test report, or if they have medium pressure duct work or, high pressure duct work, they'll probably require a duct pressure test report. So during construction phase, you'll also probably do site observation reports. I've included the software that we use, a picture of it, and this is Facility Grid. This is actually a picture from my phone of what the observation report looks like. And so in here, you can name the observation report. You can, change the status of it to in progress or completed. And then you can take pictures and upload those pictures. And it's all from your phone. So it's nice and easy because you get to use your phone's camera as opposed to a tablet or a computer camera. And it's got a flash, it's got zoom. It's just so much easier to do it on this software. And then you can also, create observations. So if, you're out on site and you're reviewing an install and it's not done, but there's a potential that the contractor may miss something during this install. It looks like he may have already missed, a circuit setter that needed to be there or something. You can create an observation and say, hey, don't forget about the circuit setter per these details. But on the other side of that, if you are looking at an install and it looks complete and it looks like they missed something, then you can just go ahead and create an issue and tag the contractor. And this software makes it nice and easy to do that. Other things to look for in your site observation report are the manufacturer approved fittings. So when they route this refrigerant and you take it and you branch off, the manufacturer typically requires these specific Y fittings that you want to verify that have been installed, and it just depends. It's different per manufacturer, but you can check for those. You also want to check for construction filters, especially for the wall-mounted units. I'm sure a lot of you have seen the wall-mounted units where the filters on those are practically, thin nylon, chicken wire type filters. They basically can't filter any, dust. They basically just filter, large particles. So I would suggest asking the contractors, if they haven't already, put, MERV 8 or above media filter on top of there during construction when all the dust is flying through the air. Other things to look for is secondary drain pans on ducted fan coil units. This is a good time to check for that, especially when they're above ceiling and the ceiling tile is still out. You can also check for float switches as applicable. They typically come with an integral primary float switch, but if the engineer wants a secondary float switch, you can also check for that. I've also included a picture of what an issue looks like in that Facility Grid app. So you can quickly type your description, take a picture, and then you can set your priority on the issue, whether or not it's, it needs to be addressed immediately, so it's a high priority. And you can also say the status of the issue. You can assign it to specific contractors, and then you can tag equipment in this issue. And then the contractor can also download this app, and then he can provide responses in this, and they would appear in the other tab, and then they can take pictures that the issue has been complete and notify you. So site observation reports, more things you can look for is verify refrigerant piping is properly connected to the outdoor units. And what I mean by don't just rely on the mechanical details. Basically, those mechanical details can be fairly generic. So I would suggest taking the install manual out and just looking through that to verify that they've installed these outdoor units correctly, based on how they're supposed to run this refrigerant piping to multiple outdoor units. I think the install manual may be more helpful than the mechanical details. Other things to look for is you can verify the indoor and outdoor units have proper clearance for maintenance and performance. The outdoor units, they need a certain amount of space to be able to properly, cool down or heat up their coil, whichever mode they're in. And then the indoor units, to get access to the filters and everything, they'll need proper clearance to be able to get at those for maintenance. Other things to verify is the condensate line is routed correctly and does not exceed the height requirements. Every manufacturer allows a little bit increase from the unit up to the main condensate line, but it's fairly small, and that's something to just check prior to going out on site. I'm not saying you have to get out a measuring tape to measure this thing, but you can, roughly eyeball it. And if it's going up 5 feet, then obviously it's probably a problem, and you can make comments on that. So once you're, past the site observation phase, you're gonna start to get ready for your functional testing. And I don't want to really dive into how to write a functional test, but maybe how to initially organize it, we'll talk about real quick, is, would you want to organize it per indoor unit, per outdoor unit and indoor unit, or do you want to just, write one large test for the entire system? And so we suggest writing one test for the entire system. I think it makes it easier while you're functionally testing that you test everything on one outdoor unit. And that's how I typically group it, as you can see in this example here. So before you, actually start doing your functional test, I would suggest, just taking a mental snapshot of the current space temperature readings and their set points on the BAS or the central controller, whatever you have on site, and just look to make sure that everything is controlling well and nothing is too far outside of their set points. Because if there is, if a room's randomly at 80 degrees with a set point of 75, then those are the ones I would hit first. So that can just give you a nice overview before you start. And actually, one time on one job we had, it was in the school. We only had ducted fan coil units, and there was random spaces that were just always in heating mode. It made no sense. I mean, it was during winter, but some were controlling just fine on the same system, and then some were, the space temperature was 85 degrees. So the contractor had actually been plagued with this issue for about 6 months, and the owner had actually already moved in, but they weren't ready for us to come out on site yet. So once we finally got out on site, we could finally start troubleshooting this issue. And me just knowing how VRFs operate, I was able to quickly diagnose a problem where they were set up straight from the manufacturer to control off of return air temperature. So these actually had a field fabricated mixed air plenum, and they still had that return air temperature, upstream of that. And so depending on where they put this outside air run, depended on whether or not this return temperature was seeing 100% outside air, 50% outside air, or just return air, which is why some of them would go into full heat and some of them would control just fine. So then we quickly went through and reset up the thermostats to control so that the unit would control off of space temperature instead of its return temperature, and that addressed the issue. So things you want to verify, during a functional test, I would verify all points that the engineer has indicated to be on the front end on the BAS. And then I would also physically go verify all commands from the BAS. So, if you're going to verify, if the BAS is supposed to be able to command these units on and off and schedule them, you want to physically go to each unit and command that fan off and then listen for it to kick off. If you're supposed to be able to control fan speed, you want to command the fan speed to high, listen for the fan to increase speed and go through all those modes. Reason being is we actually had one job where we commanded, FCU 1-1 to off, and it turned FCU 1-10 off. And we kept doing that, and it kept turning off the wrong unit. And then we go to the central controller, and the central controller had all its units labeled different from the BAS, which is why the BAS couldn't properly coordinate with that central controller on which unit was what. And so we had to get them to, rename everything in the central controller and readdress everything at the BAS, and then it finally all started to correlate. And then it also helps out the owner downstream. If the BAS is labeled one thing and the central controller is labeled another, it's just going to be annoying. And they'll probably, have to deal with that for, years until they can get someone out on site to finally change it. So the next thing to do or to determine is, whether or not to sample. And so I know this is a bit of a touchy subject, but, we believe there are situations where you can sample specific equipment. But for this type of system, for VRF systems, we suggest, just testing 100% of the equipment. I think there's just too many situations that can go wrong, and there's not enough sensors available on these units to properly, sample these things. So I would just test them 100%. The next thing to do is to verify all alarms. And, with the new IECC 2015 and even the newer 2018, which will probably soon be adopted, it requires all alarms to be tested. So that should pretty much be a no-brainer. Other things to do during a functional test is to verify design capacity on the outdoor units. So to do that, I would command all the indoor units to full cooling. And, I wouldn't, just adjust the set point a little bit. I would just go to 50 degrees, change that set point, and so everything can go into full cool, and then just go through the building and actually measure the temperature differential across the units. And this will help you verify that each unit has the right capacity, or each unit can, is receiving refrigerant flow and can maintain its delta T. And so typically you're going to look for about 15 degrees between the return and the supply. And once you're done verifying all those, I would then command the unit to heating. And again, I would go to 90 degrees. Your space should be nice and cool by the time you do that. And so it has a nice, cooling load that it has to get rid of. And it may take 5 to 10 minutes for the system to switch over to heating, but just wait a little bit and then go through and take your temperature differentials again. So if you have, a critical building, or you have an owner who actually wants to test the design capacity of these things truly, a way you can do that, and typically this is done only on cooling, but a way you can do that is by renting air-cooled load banks. We actually had a job where the owner wanted this, and so we rented the air-cooled load banks and placed them in the space, and their capacity added up to the outdoor unit. We flipped them on and made sure that the outdoor unit was able to maintain the temperature in the space. The next thing you want to do is verify the branch selectors are operational. So these are the boxes that actually control the simultaneous heating and cooling. They divert the refrigerant to and from the unit. So the way you can do this is command 50% of the indoor units to cooling and 50% of the indoor units to heating, and then wait for the system to settle out, then go out there and measure the temperature differential across each one of those units. Once you're done doing all that, then then switch them. So what was cooling, command to heating, and what was heating, command to cooling, and then go through and verify your differential again. You should still get roughly 15 degrees. So I've included an example of a functional test, and we try and make our functional tests simple, easy to read for everyone, because, technically you're writing the functional test for the owner and the controls contractor. You're not really writing it for yourself, because if you really want the controls contractor to pre-test the system, or the owner to be able to test the system 10 years later, to see if it's, kept its efficiency, then you need to make it simple for them. Otherwise, if the controls contractor can't understand your test, he's not going to use it. And so try and make it as simple as possible. The way we do this is we just have a header that simply states the mode that we're testing, and then the next line would be the action item. And this action is just what you're going to do to test the system in this mode. And then the next 2 line items, it can be 2 to 10, depending on how the unit's going to respond and what's going to respond. But those are just to show exactly, what you're testing in this mode and whether or not it passes. And then the next item is, if you created an action to put it in this mode, then you need to undo that action to put it back into normal mode. And so that's what that line item is. And then the 2 responses that are going to occur to go back to normal mode. And so it's fairly simple. You start it out in this mode, and then you take it back out, and then you move on to the next section. Other modes to test in your FPTs, depending on what the owner has or what the engineer has specified. Unoccupied modes, testing in heating and in cooling. Typically, the set points for that are 85, 55, 85 for cooling and 55 for heating. And the way I would test it is just command through the schedule, get everything into unoccupied mode, and then offset that set point to to above or below the current reading. And then that'll quickly make the specific unit that you're commanding come on. And I would test it, 1 to 2 units at a time. I wouldn't test the whole system at once, command everything, but 1 to 2 at a time, just to make sure that the system will be energy efficient and only energized to maintain its specific space. One thing I would look for when you are in unoccupied mode is when the unit energizes, make sure outside air doesn't come with it, and make sure exhaust doesn't come with it. Because it's unoccupied, you don't need those 2 things during this time. It's a waste of energy. The next mode I would test is optimal start. And so during this time, it is still considered an unoccupied mode of operation. There should be no one in the building at this time, because the building is being heated or cooled to an occupied set point prior to anyone entering the building. So again, you shouldn't need outside air and you shouldn't need exhaust, and you're just going to test the cooling and heating modes. So once you're done with that, you can verify test and balance, and you can either verify it, after your functional testing or before your functional testing. That's up to you. But and again, test and balance is going to be done differently depending on the type of indoor unit you have. So for a wall-mounted indoor unit, can they measure CFM? Can you get them to measure CFM? No, you can't. There's no real way to measure CFM on these units. You can measure a velocity, but that's about it. So really, you're looking for a temperature differential on this one, and just to make sure that the fan speeds operate. For a cassette, you can measure these. You can read the return air on these guys and then verify the CFM that way, and then get your temperature differential. For a ducted unit, that one's just like a standard fan coil or terminal unit. You can traverse it. You can read the supply grill to get the airflow, or if it has ducted return, you can read the return, and then take your temperature differential. There is one caveat to the ducted ones, and that's with the fan speed setting. So you want to make sure that whatever test and balance, did the balance at, whatever fan speed they did the balance at, and it's going to change for each indoor unit. If they balance this one at high speed, then you need to recheck the balance at high speed to make sure that it's going to match up. Because if they did it at high and you're checking at low, well, obviously those 2 numbers aren't going to match, and you're going to write up something for no reason. So, suggest that tab record the fan speed so that when you go back through, you can quickly go back to that speed and reread it. The other thing to look for is, or to even ask the owner or the engineer, is whether or not these units are going to operate an automatic or a constant fan speed. With some of these units, the difference between low fan speed and high fan speed is only 200 CFM. So, if your high is 1200 CFM, then your low will actually be 1000. But on others, they actually have a pretty high turn down rate. So at high, you can be at 1000, and at low, you could be at 500. And that could potentially, affect your balance a little bit, because anything more than a 30% difference will actually affect, your balance not falling well, if that makes sense. And it can also interfere with diffuser throw. So if you were, thinking you're going to have this throw at 1000 CFM, then all of a sudden you go to 500. Well, that may cause the diffuser to dump a little bit, over an occupant. So that's something to keep in mind. Just verify, whether or not they're going to be left at constant speed or automatic. Any questions?
Hi, Thomas. Yes, you have quite a few that are coming in, so we might not be able to get to all of them. But let's start with a few, and then if you're open to taking some questions offline via email, we could do that.
Yes, absolutely.
Okay, perfect. The first question I have is, what are some best practices or pitfalls to avoid when interfacing VRF system controls with larger automation systems such as campus-wide network?
Oh, that's a tough one. It's one we struggle with all the time. And again, it goes back to as early as possible. If you can talk to the controls contractor, and it's tough because we still struggle with it, and I don't think we've come up with a true solution as to, you know, to where the controls contractor understands exactly, you know, the points that he'll be responsible for, and then potentially, you know, providing extra sensors to be able to achieve all those points. And so I would say that the best thing to do is to look at the sequence and try and make it as clear as possible in that stage. So you may even say, you know, contractor to provide these sensors separately through the BAS, as opposed to putting them in the schedule, saying for the mechanical contractor to order these options. You know, it's just that's a hard one.
Okay. What percentage of systems do you find have an improper level of charge?
Not many. Actually, most systems are charged fairly well, but it's still worth checking because you never know when you'll come across that situation.
Okay. And this one's
And again, you can catch it. Sorry. And again, you can catch it during startup instead of catching it while you're doing your functional test, and all of a sudden your temperature differential is just not making sense whatsoever.
okay. All right, this one's a little long, but I'll do the best I can here. We've seen disappointing energy use with these systems in our climate, Canadian prairies. This is mainly due to the requirement and utilization of auxiliary heat, electrical resistance, which is typically controlled by the individual FCU controller. The auxiliary heat tends to run in OA conditions that it shouldn't, and the ability to change any parameters is limited, doing OA lockouts of backup heat, etc. This is a problem on almost every installation we've seen. Have you encountered anything similar?
I haven't here because we usually don't have auxiliary electric heat. Usually if it's a heat pump, it's just going to, you know, just switch to the heating mode. And then as far as the, you know, the dedicated outside air unit, we typically see that provided with you know, an ERV system. So I haven't had many situations where I've had to deal with that.
Okay. Do the VRF equipment items have inherent issues moving from American voltages to Canadian, or their European or Asian design, where certain components are too sensitive to these voltage differentials?
So I'm unsure about that, but I know, you know, seeing these systems in America, they've been fine. And these systems all came from, you know, roughly Japan for the most part, and they've been utilized, you know, throughout the world, I believe, way before they started coming over to America. So I don't think there's too much of an issue, but I'm not 100% sure on that one.
Okay, let's see, we'll try to get through one or two more here. On slide 19, you mentioned unoccupied set point of 58, or excuse me, 55 over 85. I was under the impression the VRFs operate most efficiently when they maintain closer to occupied set points. Is this correct?
Yes, they probably do, but again, at this point, no one's in the building, and you're actually just shutting them off at this point. So there's nothing, obviously, there's nothing more efficient than just shutting something off. So it's only going to kick back on when it actually reaches 85, 55, and then there's going to be a lot of nights when it doesn't, and so you'll gain a bunch of efficiency that way.
Okay. Is there anything you'd suggest looking for in the manufacturer's startup report? Is there any way to verify charge based on the superheat or other measurements in the startup report?
Yeah, again, I would suggest utilizing the VRF selection software. I believe you could calculate it in there quite easily.
Okay. And the last question, when would you suggest that a wind baffle be used on a VRF outdoor condensing unit?
Okay, I believe those are used for low ambient conditions, if I remember correctly. We don't, I've never had to use them here just because our winters just don't get that cold, but I believe that's what they're used for.
Okay, great. Well, I think that is about it. There might have been a few others that came in, and like I said, if Thomas, if you're okay, we could get the rest of those questions answered for you offline, because it looks like there's a couple more that are just coming in as I'm talking.
Okay.
Great. So again, everyone, the few people that didn't get your question answers, we'll get those over to Thomas and have him answer those for you. And just as a reminder, if you haven't already done so, don't forget to renew your membership so you can continue to receive these Tech Talks and all your other valuable benefits. And also the spring webinar series has been posted to our website and registration is now open for that as well. So again, Thomas, thank you. And on behalf of the BCA, I would like to thank everyone for your participation in today's Tech Talk. Have a great day.